Yeah, good day, viewers all over the world. In our last video, I told us that I'll be online to expose or help each and every one of us that be deficient in some sciences such as physics, chemistry, further mathematics, and the English language. So today we are going to start with chemistry. So before then, I would like to tell us a few things before going into the real study. This class is not only for students, maybe probably in SS1, 2, or 3. Like I said in the last video, those in 100 level will have lots of benefits of this lecture. It's just like building a house. If the foundation is not well rooted, no matter the skyscraper you intend building, if the foundation is not solidified, I tell you, one day that building will collapse. What have I seen in essence? Today we have lots of quack doctors, we have quack pharmacists, we have quack professionals in all different fields. Why? Because there are foundational problems that they are facing that if that is not corrected, there is going to be a problem. So that's why I said, let me come up with this. The issue of malpractices can be reduced if one or two students can share this to people that may think in their own knowledge that they are very brilliant. No, very intelligent. No, this is just like an expo. Let me put it that way. Ahead of your examination, if you can just stay put and take your time to study, to watch over whatever I'm going to be teaching, be it chemistry, be it physics, English language, mathematics, you may mix it. Once you mix it, go back and watch the video. And I tell you, if you can watch it first time, second time, third time, fourth time, there is no way you don't understand it. All these things, somebody started this curse. Somebody started it. Sir Isaac Newton, he's not a ghost. He's equally a human being the way I am. So he studied it and he was successful with it. The same way, everyone who followed the principle, like I always say, I always tell people that principle is universal. Whatever you apply as a principle in Nigeria can equally work in the UK or in the US or any part of the Asia country. Just apply the principle. Principle is always constant. Once you apply that principle, I tell you, you are good to go. Water in Nigeria is the same water in Canada. So water is water everywhere. If you say apply heat to water, it will boil. If you apply same heat at the same temperature they have told you to apply it will also boil in another part of the world. So today I'll be talking about chemistry. And before we start, I want you to subscribe because I don't want to mix any of my videos because it's going to be a stepwise building. You can't jump from foundation to saying you want to be laying blocks. No, you have to build the foundation, start laying blocks. When you get to lintel to where you start roofing, then you may now say, okay, oh, I want to do a, what do you call it, plaster. I want to do this. I'm talking about constructions. So the same way, for just follow my videos, and if you can follow my videos one after the other, I tell you, you become a genius, a guru, a sudden genius. So mothers, fathers, this is a very good package you can give to your children to help them academically. Please, this video or my lecture are going to be practical oriented. I'm not here to be teaching theories. No, I'm a practical person. I've practicalized whatever thing I want to teach in these sciences. So let's start. Don't forget to subscribe. Subscribe, like it, share it. It's very important. If you're a student and you're watching this, share it. If you don't share it, then you're being selfish. So try to be what? Generous. Let people subscribe so that I can be encouraged to do plenty of the videos, so that I can have exposition of knowledge. Yeah, today I'll be talking about chemistry. But before chemistry, something must have occurred or existed before chemistry will start as a course. I can remember though that back then when we were in secondary school, we used to have something they call integrated science, only for me to know of recent that it is not basic science. So either science, integrated or basic science, just follow what I want to explain. Because they will tell us then integrated is this. No, just come. We are going to break everything into pieces. Just follow it. Don't try to do that popular balance in Nigeria. I'm a Nigerian. They call it ITK. It means I too know. Don't form I too know here. Just be open. If you are open to knowledge, you are going to get it very smoothly. So today I'll be talking about chemistry. Then when we're in SS1, they told us that your integrated science will have branches. We have chemistry for those who want to go to science class. You're going to have physics. Then you have biology. So those are the three classes they grouped this integrated science or basic science, as it's may be called today. So today we are going to be talking about chemistry. In another video, I'll be talking about physics. In another video, I'll be talking about mathematics, then English language, another class. So today we want to talk about chemistry. Chemistry. What is chemistry? You know what? Let me just tell you. As a physicist, what am I holding? I'm holding a marker. A physicist will tell you the dimension of this marker. A physicist can only tell you that this marker is writing black, as you can see on the board. But as a chemist will not tell you that this is a marker. He won't tell you about the dimension. He will tell you about the matters that would have come together to produce this marker. You know, in chemistry, you say matter exists either as a gas or liquid or solid. That is a matter. And we know that all these matter, they are made up of what? Elements. Now, maybe like 103 elements. No, don't worry, we'll soon get to that. So they want to say, how can this gas or gases or liquid combine together to form this plastic? That is what a chemist is all about. A chemist will tell you about. Even we're talking about the black, the color of the marker. A chemist will not tell you about the color, or is not concerned about whether it's black. What they are concerned is about the chemistry, the chemicals, the composition of this black color, how they will react, whether they will form a compound or it's going to be a mixture. That is what a chemist is all about. Chemist will always talk about. But today we are starting chemistry. Even if we don't even have any knowledge about science, if you can follow this video, I tell you, you can challenge anybody in science class. Even if you have gone to what they call the commercial class, you finish from there, or you are in commercial class, you can equally watch this and challenge whoever in science class and even debate with them if you can watch it consecutively, because I'm going to pieces everything. So today we said chemistry is concerned with physical and chemical changes. Physical and chemical changes. Chemistry is divided into three parts. Chemistry divided into three parts. One, I'll be talking about organic chemistry. Two, talking about inorganic chemistry. On the third part, I'll be calling it calculations in chemistry. You know what? The way I will teach it, just follow it this way. You can never miss it. In your knowledge, just know that chemistry is divided into three parts: organic chemistry, inorganic chemistry, calculations in chemistry. But I'll start with organic chemistry. There is no way you will not be talking about inorganic chemistry in organic chemistry. There is going to be inorganic chemistry class. There will also be calculation. Where we just be doing calculation of both inorganic chemistry and organic chemistry. So today I'm going to start with organic chemistry. Organic chemistry. Organic chemistry. Because I want to make it to be very practical. I'm not here to be rolling any slides. It's real. This is not a cartoon doing anything. It's real. I'm here teaching you life. So organic chemistry. Organic chemistry is the study of carbon and its compound. Carbon and its compound. Under its compound, we can be talking about oxygen, carbon and oxygen, carbon and nitrogen, carbon and sulfur, carbon and... So under organic chemistry, there is something we call hydrocarbons. Hydrocarbons. Because that is the organic chemistry we are talking about. Then the question comes, what is the meaning of hydrocarbons? Hydro, carbon, hydrogen, carbon. It means hydrogen and carbon only forming the reaction. We have only hydrogen and what? Carbon in the reaction. And they may ask you, how do we come about hydrogen and carbon? There is no magic. It's not a rocket science. Hydrocarbons are gotten chiefly. I repeat, hydrocarbons are derived or are produced or are synthesized or are gotten, whatever grammar they may want to use. The point there is that you want to know how these hydrocarbons are gotten. Hydrocarbons are gotten from crude oil. I know those of you in Canada and the US, you will know about crude oil. Nigeria also, we have plenty of crude oil. Crude oil, or they call it petroleum. I don't know why you are calling it in Canada, but in Nigeria, we are so familiar with this word. Crude oil. In other parts of the world, they can call it petroleum. Are we together? In Latin, they don't call it petroleum. They call it rock oil. Rock oil. In Africa, we call it black gold. Black gold. The basic thing is that how are these things gotten? As in crude oil, petroleum, rock oil, black gold, whichever they want to call it. How are they gotten? They are simply gotten from dead algae or dead animals inside the water. By the time they die, pressure will act on them, they will decay. A whole lot of chemical changes will happen to them. Pressure, heat, mud will be added to that decayed algae to form a sediment. In geography, they'll talk about sedimentary rock. To form a sediment. So these sediments will undergo lots of processes in which they will now have to transfer from one seabed to another to generate this our crude oil. Geology, they will testify to all what I'm saying. Geologists, they will testify to this. or petroleum engineers. So that is just by the way. Our center of discussion today is hydrocarbons. So I just decided to digress. Maybe another time will come where I will talk about refinery. Although there I will explain fractional distillation, how all these things are being separated, how to get what do you call it, methane, how to get ethane, how to get propane, how to get butane, how to get all those things, how they derive at petrol. And let me tell you, petrol is not the same thing as petroleum. Petrol is one of the byproducts of petroleum. I'm saying it again. Petroleum is the parent name. Petrol is one of the constituents. After fractional distillation, you are going to get petrol. You get what they call it, the gases. You get kerosene. You get diesel. You get oil. You get bitumen. As far what have you? So petroleum or crude oil is as useless as anything when it is not refined. You know, before now, petroleum always occur with what do you call it? Natural gas. When you hear natural gas, they are talking about methane. Natural gas means methane. So don't let me waste much of our time. So let's go into hydrocarbon. 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 As a course now. As a topic. Hydrocarbon. 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 Hydrocarbons. There are two types of hydrocarbons. One, we have aliphatic hydrocarbon. Then we have aromatic hydrocarbon. Under aliphatic hydrocarbon, we have acyclic aliphatic hydrocarbons. No, don't disturb yourself with all these jargons. Acyclic, meaning it is not cyclic. Acyclic aliphatic hydrocarbon. Then we also have cyclic aliphatic hydrocarbons. Under aromatic hydrocarbon, we have benzene. 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 That one has the structure. Lord, I'll be teaching us more of this. Kekuli structure. Because I'll be picking them one after the other. Under acyclic aliphatic hydrocarbons, we have, your textbooks, they will tell you divided into 3, but I would like to divide into 4 for better understanding. We have alkyl, we have alkane, we have alkene, and we have alkyne. Acyclic aliphatic hydrocarbons, they are straight carbons or branched carbons. Cyclic aliphatic hydrocarbons, they form ring. Then we're talking about maybe, for instance, we have something like 3-methyl cyclopentane. By the time we get there, I will explain everything. So we have alkyl, we have alkane, we have alkene, we have alkyne. I'm going to be picking one after the other to do justice to them. That's why I said, don't mix any of my videos, please. Today, I will do justice to alkyl and arcane, archeo, and arcane. Before then, I would like to tell us the general nomenclature of hydrocarbons. You know, like I told you, hydrocarbons can exist as gases, as liquids, or as solids. That was what I was telling us about fractional distillation. The first thing, by the time you eat the crude oil under a very high temperature, maybe 400 degrees Celsius to 500 degrees Celsius, more than that, the first thing that will come out, let's say between 4 degrees to 100 degrees Celsius, are the gases. Things like methane, things like ethane, things like propane. No, don't disturb yourself. By the time you get there, you understand it better. That will come at the end. Now have liquids. That's where you have things like the ethyl ether, volatile liquids. The ethyl ether. We have petrol. We have kerosene. We have diesel. Just follow it. Very simple. Just follow it. I'm going to demystify it. So let me go to general nomenclature of hydrocarbons. Now you all see that hydrocarbons is not magic. It's not falling from anywhere. It's what you know. It's from it's from what the crude oil. If you're in Canada, if you're in US, if you're in Russia, Venezuela, Nigeria, I'm telling you places that have oils. I think China also. So please, just follow it. Follow what I'm teaching. It's very simple. Organic chemistry. Very simple. Chemistry generally. So, too simple. Alright. So, we said, you're under general nomenclature of hydrocarbon. HC. Hydrocarbon. HC. Hydrocarbon. HC. I don't use that so that will save time. So we say one, homologous series differs by CH2. I will explain it. Two, they obey the law of tetravalency. I will explain that. Although I would like to explain more of this under inorganic chemistry, but we will not talk about it here. So they obey the law of tetravalency. Three, they undergo substitution or addition reactions. But your arc A will not undergo addition reaction. You still know why. So I'm just giving you the general characteristics of what? Hydrocarbons. Now, let me now pick arc A. Let me start with arc A. You know, I told you in this video, I will talk about arcane and archeo. We have arcane. 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 Arcane has the general formula or general molecular formula of CnH2n plus 2. I repeat, alkanes have the general molecular formula of CnH subscript 2n plus 2, where n is greater than or equal to 1. Listen, in mathematics, n greater than or equal to 1 is not the same thing as n greater than 1. In mathematics, I will explain that. When you say n greater than or equal to 1, it means the first value of n is 1. I repeat, when we say n is greater than or equal to 1, it means that the first value of n is 1. Can that be 2, 3, 4, 5, 6, and so on and so forth? But when I say n is greater than 1, it means that the first value of n is 2, not 1. I repeat, when I say n is greater than 1, it means that the first value of n is 2, not 1. Let's now come to this. We have Cn H2n plus 2. We have different types of alkane, in which I will list them one after the other. I'll list 1 to 10. 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number 1 is called methane. Methane. Next, what is the molecular formula? How is it gotten? How is it generated? How do I get the molecular formula of methane? Methane has, look at the serial number. When n is equal to 1, we put it here. So that we now have C, let me write again, CnH2n plus 2. That is the general formula for alkane group. If, or when n is equal to 1, we have C1H2, this is n, into bracket 1 plus 2. This is equal to C, this is 2 times 1, 2. 2 plus 2. That is what? 4. So, the molecular formula of, this is chemical name, the molecular formula of methane, I repeat, the molecular formula of methane is what? CH4. There is no magic here. You can see where I got the CH4. No magic. CH4. The structural formula now. Structural formula. My board is getting filled. Let me clean some parts. It's getting filled. Let me clean some parts. Like I told you, I don't need to show you any slide, though. I want you to see it happening real. Real. Structural formula. Remember what I told you? That alkanes or hydrocarbons, they obey the law of tetravalency. Meaning that 4 bonds must surround the carbon atom. When it is a single bond, we call it what? Sigma. Sigma bond. By the time we get to alkene, I'll be talking about double bond, where this one will be a sigma bond and this one will be a pi bond. You can easily break a pi bond, but sigma bond, no. Very hard. That's where, under inorganic chemistry, I'll be talking about ionization energy. There they will tell you the first ionization energy, the energy required to remove an atom from the surface, the electron from the surface of an atom. Then the second ionization energy, is more than the first one. The third ionization energy, you will soon understand all that. So it's from here. That is why alkene alkyne can undergo addition reaction, they can undergo substitution reaction. But for alkane, they can't undergo that. They can only undergo substitution reaction. So law of thermodynamics now. How many hydrogens do we have? We have 4. It means that 4 hydrogens will now surround this carbon. CH4. This single bond you are looking at, like called sigma bond, consists of what? 2 electrons. I will still explain that maybe by the time I start talking about electronic configuration. But just note that whenever you see dash, it means 2 electrons. This will bring an electron, this will also bring an electron for them to form a bond. Alright, so we have CH4. Like this one now, this is structure. That we call structural formula. This is now what? Structural formula of methane. Structural formula of methane. This is the molecular formula. Structural formula of methane. I want to believe I made myself clear enough. The second one is called ethane. Look at the words. Methane, arcane, ethane. Third one, propane. Because it belongs to arcane group. So it will always carry A-N-E. We have butane. We have pentane. If you remember your regular polygon or your polygon in mathematics, they will tell you 5 is pent, 6 is x, 7 is ect, 8 is oct, 9 is non, then 10 is deca. The same way, you have got it to pent A, then 6 will be what? X A. 7 will be what? Ect A. 8 will be what? Oct A. 9 will be what? Non-name. And 10 will be what? Decane. So I've listed 10. But the only thing like I told us, I will only do for maybe like 1, 2, 3. Then the rest will be your own exercise. If you have any problem, you can always drop it in the comment section where I'm available to answer it. So we have CH4. The next one is 2. Then you go back to the formula again. CN